looking at mixed exercise 9 from the first year core textbook, and we're on question 2. So we're looking at trigonometry. And we've got 3 triangles and we need to find a missing angle and the area of each one. Okay, so right. So what can I use to find the angle for A? Okay, so I can't use sine rule. I find sine rule easier than cosine rule, but I'm not given any angles, so this is going to have to be cosine rule. Okay, so if this is the angle that I want, then this is the side that will be the subject of cosine rule. So it's going to be 2.4 squared is 3 squared plus 1.2 squared minus 2. So hopefully you're familiar with cosine rule, or you'll need to just go and have a read up on that. Okay, so I know some people do use the rearranged version of cosine rule where you have the angle as the subject. So if you prefer to do it like that, then that's absolutely fine. Okay, so what's that going to give me? So 2.4 squared. Oh. Okay, so 3 squared plus 1.2 squared. Times 2. Okay. Okay, so I'm going to add the 7.2 cos x over to the left-hand side and then do 10.44 minus 5.76 and get 4.68. So cos x is 4.68 over 7.2. So x is arc cos of that, which is 49.5 degrees. I'm just going to check that. Because I've typed something into my calculator. No, we're good. Okay, and then area. I thought I would just go back up, do that up there. Okay, so that's x for the first one. So the area is half. Oh, sorry, I can't see what I'm writing. Okay, so again, right. Okay, so area is half AB sine C, and this is the angle I've got. So those will be the 2 sides I use. So half times 3 times 1.2 times sine of that angle that we've just found. So sine 49.5. And I haven't cleared the 49, that answer for my calculator. So when I type it into my calculator, I can actually use the more accurate version. So I'm just going to do sine of answer and then times 0.5 times 3 times 1.2. So I'm getting that to be 1.37, and I'm guessing we were in centimetres. Yeah, so 1.37 centimetres squared. And again, let's just double check that before we move on. Yeah, we're good. Okay. All right then. So is question B the same? No, question right. So question B, we're going to be able to use sine rule, which just makes it a little bit easier. Because for B, I have got an opposite pair where I've got the length of that side and I've got the angle of it, I've got the opposite angle. So I can use sine rule there. And for sine rule, it's easier to have the unknown in the numerator of your fraction. So it's easier to say, to have it as sine x over 5 equals sine 80 over 6. It would work if you had those fractions the other way around. So 5 over sine x and 6 over sine 80, it would work. It's just a little bit easier this way, because then I can say sine x is sine 80 over 6 times 5. So I'm just going to put that straight to my calculator. So sine 80 times 5 all over 6. So I get that as 0.82. And I'm just not going to clear that from my calculator. So let's just move up a little bit. So x is arc sine. But I didn't really have to work that out as a separate stage, to be fair. I could have just done arc sine of all of that. Okay. So arc sine all of that gives me 55.2 degrees. And then, oh, okay, right. So this then does, oh no, so now I'm going to do area, and I'm going to do half value, so half AB sine C. So I currently don't have any two sides and the angle between them. So I'm either going to have to find this missing side or that missing angle. And I would say it's a lot easier to find the angle, because now I know, that that is 55.2. I can just do 180 minus that, minus 80, and get the third angle that I need. So I think that's definitely the easiest way to go there. So that's that angle there. So I'm going to use, therefore, those two sides and that angle to find the area. So it's half times A times B times sine of angle C. So that's going straight into my calculator. And again, I haven't actually, the 44.8, I've got more accurate on my calculator because I just didn't clear it. So times 6 times 5 times 0.5. So I'm getting that area to be 10.6 centimetres. Is it centimetres again? Yeah. Okay, and let's just double check. 10.6 and 55.2. Yeah, we're on a roll. Okay, so then C, I'm assuming, is a little bit different again. Okay, so let's see what information they give us for C. Okay, so rough sketch. I've got that angle. I need to find that angle. I've got those two sides. So I wouldn't be surprised. I don't have to use both of them for this one. Let's see where they're going with this. Okay, so I can, oh no, I think it's all right. So I think I can use sine rule again. In fact, I can use sine rule. But when I use sine rule, I'm actually going to find that angle first. But then obviously if I've got that angle, I can just subtract from 180 to find x. So I can say that, oh no, oh yeah, sorry. So I'm going to call this one theta. Okay, so sine theta over 3 is sine 40 over 5. So sine theta is sine 40 over 5 all times 3. So theta is arc sine of all of that. So you can just put that into a calculator in one go. So arc sine of sine 40 times 3 over 5 is, theta is 22.7 degrees, but oh, you can see, but obviously that's not actually the angle I was asked to find. So that is that angle there, but then I can just do 180 minus 40 minus 22.7, and that's going to give me angle X. So angle X of 117. Well, I want it to be significant figures, so 117 is fine. Okay, and then let's just be really clear that is my answer for angle X. Okay, and then yeah, so now we've got angle X, area, nice and easy. Half times 3 times 5 times the sine of the angle between them. Yeah, I'm just using those two sides and that angle to find the area. So sine of answer. So again, I haven't cleared the 117 from my calculator, so I'm actually using more accurate value in that. And that gives me an area of 6.66. Yeah, it's in centimetres. Centimetres squared. Okay, let's just check those last two, 6.66 and 117. Fantastic.